The K-nearest neighbors, KNN, algorithm is a popular machine learning algorithm used for classification and regression problems. It is a type of instance-based learning or lazy learning algorithm that doesn't require any explicit training process, as it stores all the available data points in memory and performs classification or regression based on the similarities between the new instance and the stored instances. Here is a detailed description of the KNN algorithm. Collect and preprocess data. The first step is to collect and preprocess the data. This includes removing any missing values, scaling the features, and splitting the data into training and testing sets. Determine the value of k. The next step is to determine the value of k, which is the number of nearest neighbors that will be used to make predictions. This value can be determined using cross-validation or other techniques. Calculate distances. The KNN algorithm uses a distance metric, such as Euclidean distance, to calculate the distance between the new instance and all the stored instances in the training set. Find k nearest neighbors. Once the distances are calculated, the KNN algorithm identifies the k nearest neighbors to the new instance based on the distance metric. These nearest neighbors are the ones with the shortest distances to the new instance. Determine the class. For classification problems, the KNN algorithm determines the class of the new instance based on the majority class of its k nearest neighbors. For regression problems, the KNN algorithm determines the predicted value of the new instance based on the mean or median value of its k nearest neighbors. Evaluate the model. The final step is to evaluate the performance of the KNN algorithm using a variety of metrics such as accuracy, precision, recall, an F1 score for classification problems, and mean squared error, root mean squared error, and R-squared for regression problems. Advantages of the KNN algorithm include its simplicity, flexibility, and ability to handle both classification and regression problems. However, it can be computationally expensive for large datasets, and it requires a distance metric that is appropriate for the data. Additionally, it is sensitive to the choice of k and can be affected by the presence of noisy or irrelevant features.